Let us look at solving system of linear equations. Now, in the first session itself, while introducing matrices, I had shown you a system of two equations in two variables. And I had shown that this can be represented in matrix form as this. So we had not really gone into solving this equation. So, but now we have the underlying principles clear in our mind to solve these type of systems of equations. But let's go with a slightly bit more a comprehensive example, and we'll solve it using the matrix method. Now, we are going to use a system of three equations in three variables. So we have three equations and the three variables are x, y, and z. Now here A is equal to the coefficients of these variables. X is the matrix which has the variables and B is the matrix which contains the constants. A is called the coefficient matrix. The metric equation becomes A times x equal to B. Now, to solve for x, we left multiply by the inverse of a on both sides so that a gets cancelled in the LHS. But remember, inverse exists only if the determinant of a is not equal to 0. That is, a is non-singular. So let's evaluate the determinant of a. Since it's a 3 by 3 matrix, we start off 1 along the first row. 1 times minus 2 plus 1, because minus 1 becomes plus. So minus 2 plus 1 minus 1 times minus 4 plus minus 2 times minus 2 minus 4. And if we start simplifying it, we end up with 3 as the determinant of A. Now, since determinant of A equal to 3, which is not equal to 0, inverse of A exists. That means we can solve this equation. So we have A times x equal to B. Left multiply by A inverse on both sides. So here on the left hand side, A inverse times A becomes I sub n, and I sub n times x is equal to x. So we have x equal to A inverse times B. Now how do we figure out A inverse? We have already seen this and we know the process that has to be followed. So that steps to find the inverse are submatrices, determinants of the submatrices, that is the minus, build the cofactors matrix, transpose the cofactors matrix, then use this formula. A inverse is equal to 1 by determinant of A times the adjoint of A. So let's proceed step by step. So first step is submatrices. Remember submatrices? Start with A11, that is 1. So remove this first row, first column to which this 1 belongs. A11 belongs. So what is remaining is our submatrix. So 1, 1, minus 1, minus 2. Similarly, A12. A12 is this. So this row, that is the first row and the second column we remove. So we have 2, 1, 4, minus 2. Like that, we write down all the submatrices. The third step is, or rather the second step is determinants of the submatrices. That is a minus. So the determinant of A11 is equal to minus 2 plus 1. So minus 2 plus 1 is minus 1. Minus 4 minus 4, that is minus 8, and so on. Okay. Now this is our cofactors matrix. What have we done? We have taken the minus and we have incorporated the positional signs. Minus 1 to the power of I plus j. So 1 plus 1, 2 plus 1, 3 plus 1, and so on. And evaluating these signs and simplifying, we get minus 1, 8, minus 6, 0, 6, minus 3, 1, minus 5, 3. What is the next step? Transpose the cofactors matrix. So to take the transpose of this matrix, we get minus 1, 0, 1, 8, 6, minus 5, minus 6, minus 3, 3. And this is the adjoint of A. What is the next step? Now use this determinant of A and the adjoint of A to evaluate the inverse of A. So let's do that. So our formula is A inverse is equal to 1 by determinant of A times the adjoint of A. So A inverse is equal to, remember the determinant is 3. So 1 by 3 times the adjoint of A, which is what this is. Now, getting back to finding the solution for x equal to A inverse times B. So x is equal to A inverse times B is equal to 1 by 3 times the adjoint of A times 3, 5, 1. This is the matrix of constants. Now multiply 1 by 3 times minus 3 plus 0 plus 1. 3 8 24 plus 30 minus 5. 6 3 is 18 minus 18 minus 15 plus 3. Simplify it to get 1 by 3 times minus 2 49 minus 13. Simplify it to get xyz is equal to minus 2 by 3, 49 by 3, and minus 10. So here x is minus 2 by 3, y is 49 by 3, and z is minus 10. So that was solving a system of linear equations, that is with 3 equations and 3 variables using the matrix method. That's it for now. Bye.